Okay, so last class you guys were asked to look at a series of 4 graphs and decide which one of those could possibly represent circumference and diameter relationship between circles. And then you were asked to go to this GeoGebra task and look at diameters and their matching circumferences so that we could actually establish a graph. So I'm going to do a little bit of a shortcut here. I'm going to go from the corresponding diameter and circumferences I find and put them right into a second GeoGebra window where I'm in Graphing Calculator. If you're not sure how to get to the Graphing Calculator in GeoGebra, if you just type in GeoGebra into your browser, mine automatically goes there, but you can either click on this Start Graphing button here or click on the Graphing Calculator link and it will bring you into the Graphing Calculator. So for today, I'm going to look for a nice diameter and a circumference that match together, and I'm going to get 10 points, as I asked you to, and put them into GeoGebra so that I get a nice line. Now, ideally, this is going to be linear, because we decided it should be linear, and it should cross through the origin on the y-axis, so let's see what we get. So the first point we have is 8.3, 26.1, and remember that when you enter points into GeoGebra, we put them in coordinate style because they are coordinates, which means that we put them in as x, comma, y in brackets. The nice thing about GeoGebra is that it forces you to have good communication skills. And 5.3, 16.5. So 322.8. Nine point 7, 3.6. And I'll complete that later. Okay, so I now have all of my points plotted, and you can't really see them because they're outside this window, so I need to drag and also shrink, and my point H is not falling inside the usual range, so I'm going to double check that one because that looks weird. Circumference 1.7, 5.2, so that's weird, isn't it? And we'll go with this one instead. .5 and 11. Oh, H, 5.3, 13.1. It's supposed to be 16.6, so we'll fix that. This is the nice thing about outliers is they show you where you're wrong so that you can check and make sure that you are doing things correctly. So this doesn't give me a line, and what I would like to get out of this is an equation. I don't have one right now, so I need to create a line of best fit. So a best fit line is a line that best fits the data. This is data that's been collected, so there's some rounding error here. I mean, it was computer generated, so there shouldn't be any like measuring error, but there is rounding error, so it's not going to be perfect. It won't make a perfect line. So we make a line that best fits the data, and then we get an equation for that line instead. Now, this best fit tool only lets you select 2 points. So it's easier if you actually generate your fit line in the input bar. So I'm going to type in the words fit line, and it's going to give me what I want with a list of points. Now I just list the points that matter. So A to J, A, B, B, and J. And you'll see that I have a nice, beautiful y equals mx plus b format equation down here. So this equation I'm going to actually input into Google Classroom as I asked you to in the instructions. And I'm going to round this one because my data is only accurate to the 10th. I only got measurements to the 10th. So I can't put 3.165178 because I'm only sure of 3.2 because 16 is going to round to 2. So my equation is actually going to be y equals 3.2x. That's it. Minus 0.2. And that line lays right over top, so that gives you a good sense of how similar the lines are to each other. And that's what I'm going to enter in here. So I would like you at this point to take a screen capture. Once you enter in your own points, take a screen capture of your graph. You can also go up into the menu here and export the image, and that'll save it for you. And then share that with me in Google Classroom or submit through Google Classroom along with this equation along the bottom.